We are starting with the concept of histogram. Histogram is another diagrammatic representation that is used for displaying data that is easy to understand and easy to read. Histogram is not used for raw data, it is used for frequency distribution, and not just any frequency distribution. This is specifically for grouped frequency distribution. What do we mean by group frequency distribution? Data that is there in terms of class intervals, in terms of class boundaries. That leads us to the very first question. What's a class interval, a class boundary? Let's see. Choose some colors. Class interval is something like 10 to 19, 29, 30 to 39, and so on. Right now, we are not discussing whether it's equal class intervals of equal width or unequal width. We are not talking about that right now. When I want to talk about boundaries, the thing is, it's ending at 19, it's starting at 20. It's ending at 29, it's starting at 30. So there is a gap of 1 unit. Now that gap of 1 unit should be taken care of. That means this is something like, if I draw a number line, and this is like 10, 19, and then 20, 29. In a histogram, we draw vertical bars, and those bars are joined as compared to a bar chart. Now, how can I do the join? Let's to move ahead 0.5. Let's still 19 to move ahead, still 20 to move back 0.5. That means this is 10, which will be changed in a short while. This is 19.5, and this is 29. That means they agreed on this number, which is 19. The upper class interval moved ahead 0.5. The lower class interval moved back 0.5. And this is not just specific for these two numbers, this is specific for all of them. That means 10 would become 9.5, 29 would become 29.5, and so on. Hence, the class boundaries are 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5, and so on. So this is the first and the foremost knowledge that you need about drawing a histogram. Second thing, what is class width? There are two ways of explaining class width. First way, upper class interval minus lower class interval plus 1. So I stands for interval, B stands for boundary, UC upper class, and LC lower class. So upper class interval minus lower class interval plus 1, that means 19 minus 10 plus 1, that comes out to be 10. But since I'm using the concept of class width for histogram, so let's just stick with one rule, which is upper class boundary minus lower class boundary. Why? Because you would be changing it to boundary anyway. So why depend on the interval? Just focus on the boundary. It's simple for you, it's simple for the examiner. That means 19.5 minus 9.5, which comes out to be 10. 29.5 minus 19.5, which comes out to be 10. For example, there was a class interval 30 to 79, for example. So 30 to 79 would become 29.5 to 79.5. Therefore, the boundary, the class width would be 79.5 minus 29.5, which comes out to be 50. So that should be calculated. So what have we studied so far? Histogram, it's basically for group frequency distribution. We are dealing with class intervals. They need to be changed to class boundaries, and class width is upper class boundary minus lower class boundary. Now, this thing is done. Histogram with equal class width, that is pretty straightforward. If it's equal class width, all you need to do is to have a vertical axis. You have to have a horizontal axis. You mark frequency on the vertical axis. You mark boundaries on the horizontal axis. And you would have different kind of bars drawn. All the bars will be of equal width, right? I'm just drawing a rough diagram. So if they are not equal, bear with me. Something like this. And then something like this. And then something like this. And the last one is maybe something like this. So that is an example of histogram with equal class width. Frequency goes at the top along the vertical axis and boundaries over here. So this could be 0, this could be 10, this could be 20, 30, 40, 50, 60, something like this. But this is so basic that the examiner usually doesn't ask for histogram with equal class width. It asks for histogram with unequal class width. That's the challenge. Whenever it's histogram with unequal class width, remember the concept. Frequency density is frequency, class frequency over class width. And this time what will happen is that your horizontal axis would still be boundaries as before. And your vertical axis will be frequency density. The class widths will be unequal. One could be like this. Other one could be like this. Third one could be thinner. Fourth one could be the original size. And so on. So this could be something like, let me label it. This is 0, this is 10, this is 30, this is 35, this is 45, and so on. So now the graph would look like this. This area would now be equal to frequency. What is the difference between this one and the previous one? Over here, frequency is basically the height. And in this one, area is equal to frequency. Why? If I just look at this formula, the formula is frequency density is class frequency over class width. If I multiply these two, frequency density into class width, so frequency density multiplied by class width, that is class frequency. This is not cumulative frequency. We have not started it as yet. That means if I look at the bar is something like this. This difference is from here to here. This is class width. The height is frequency density. Therefore, this region on the inside, that is the area, which is frequency density into class width. So therefore, this area represents frequency. That is the logic behind it. So now let's move on. Let's look at this table. The boundaries are already given. Corresponding frequencies are given. You need to do some calculation in order that your data is ready to be fixed on a diagram which shows a histogram. First of all, let's fill in the column for class width. The class width 5 and 10 is 5. Let me just thin out the marker a bit. So therefore, the class width is 5. The class width is 5. The class width is 5. The class width is now 10. the class width is 10, and the class width is 30. And the order in which I have written, that makes pretty much sense. Frequency density divided by, frequency divided by class width should equal to frequency density. So this is like A divided by B should equal to C, something like this. Now 8 divided by 5 is 1.6. 10 divided by 5 is 2.0. 13 divided by 5 is 2.6. 9 divided by 10 is 0.9. 7 divided by 10 is 0.7. And 5 divided by 30 is 0.2. Check my calculations again. This thing is done. Now, what is the rule? Frequency density should go on the vertical axis, boundaries would go on the horizontal axis. But look at the frequency densities, they are too small. That means scaling needs to be done. So I need to do scaling. I need to get the height in centimeters. Therefore, scaling is a must. So therefore, what should you do? This biggest value is 2.6. Can I write 2.6 as 13 centimeters? So 2.6 can be written as 13. And 2 can be written as 10 centimeters. And 1.6 can be written as 8 centimeters. And 0.9 can be written as 4.5 centimeters. 0.7 can be written as 3.5 centimeters. And 0.2 can be written as 1 centimeter. That means the scaling that I have chosen is that I have chosen that one frequency density is basically half a centimeter. Let me write it. 1.6 frequency density, and this is the height in centimeters. That is 8 centimeters. In other words, I just felt like it because if I made 2.6 as 26, that would be too high and that would maybe crossing the boundary of the graph paper. In other words, if I say 1 centimeter, this is x. So I can say 8x is 1 into 1.6. Therefore, x comes out to be 8 divided by 1.6. That comes out to be 5 units. That means the scale that I have chosen is that 1 centimeter or 5 units on vertical axis is equal to 1 centimeter. So that is the scale I have chosen. Done. Now, what's the last thing? The last thing is drawing the histogram. So now when you draw the histogram, what do you see? You see this table, and you have 1.6, 2.0, and 2.6. So let me label it first, starting, let's label it in values, and it's going all the way till 2.6, that value. Let me first label it, and then I'll remove the dots. So this is like 26, so 5 centimeters, will it make sense? 5, 10, it won't fit in. So let me make it like this. This is 0.5. No, it would exceed it. So let me make it, this is like 0.5. This is 3, and this is 1.0. And 3, this is 1.5. And this is 3, this is 2.0, and 3, which is 2.5. Okay, approximately, and let me remove this thing. Okay, so now from 0 to 5, the frequency density is 1.6. You will be labeling the frequency density, but on the graph paper, you have to take care of the scale. So first and foremost, between 0 to 5 is 1.6, something like this. Okay, it's just a rough graph. And then 10 to 15, this is 5 to 10, my bad. 5 to 10, let me remove it. So it's like this. Between 5 to 10, it is something like 1.6. And then the other one, 10 to 15, is 2. 10 to 15, it's 2. So it goes like this, something like this. Third one, 15 to 20 is 2.6. 15 to 20 is 2.6. That is something above this. Okay, it's not the exact one, it's just a rough one. And then 20 to 30, that's 4.5. 20 to 30 is 0.9. So 20 to 30 is 0.9, something like this. And then 30 to 40 is 0.7. 30 to 40 is 0.7. 0.7 is something like this. And the last but not the least, that is 40 till 70, that is only 0.2. So that's how the histogram is drawn. Frequency density on the vertical axis, and on the horizontal axis, you have the boundaries. Now, this thing is done. The scaling part is understood. Now, let's look at this question. Past paper question. The following histogram represent the length of worms in a garden. Okay, calculate the frequencies represented by each of the 4 histogram column. Very simple. Just read the scale properly. This is 4, this is 8, this is 12, this is frequency density. And this is the length in centimeters. That's the boundaries. And in the first one, it's pretty straightforward. This is 1, 2, 3, this is 2, this is 5. So this area 1, so area 1 is 10. Similarly, 5 to 10, this is 8. So area 2, so area 2 is 5 into 8, which is 40. Area 3 is 10 till 20, that is 10, and the height is 12. So area 3, that's 10 into 12, that's 120. And the last one, 20 to 25, that's 5, and that is something like this thing. So I think this is 1, 2, 3, 4, 6. This is 6. And area 4 is 6 into 5, which is 30. That means how many pieces of information were there altogether? 10 and 40 is 50. 50 and 30 is 80. 80 plus this thing. There were total 200 worms that were taken into account. Okay. Now, if someone makes a question, for example, if I focus on the last one and this value is unknown, maybe the scale is not given or something like this, or this thing, for example, is unknown. They have written A and they have maybe just drawn this part of the graph, so I cannot label the axes. I cannot read from the axes. And the question would be something like this, that for the, let me cut paste it. The question would be something like this. There were 30 worms. I think there were 30, right? There were 30 worms in this one. The frequency density was 6. This thing is A. Find A. So you would say frequency density is class frequency over class width. Let the frequency density is 6. And class frequency is the number of worms. Class width is D, or W is better. So therefore, W comes out to be 30 over 6, which comes out to be 5. Since the interval is written as X lying between 20 and A, and the class width is 5, therefore A should be 20 plus 5, which comes out to be 25. That means A minus 20 gives you the class width, right? So therefore A comes out to be 25. So they can make a small question like this also. Okay, Let's move on. Let's look at this question. A random sample of 97 people who own mobile phones was used to collect data. The data is given. It's already given as boundaries. It's ending at one value, starting from the other, ending at one, starting from the other. So it's already boundaries. Number of people is there. Let's focus on the second part. On graph paper, draw a fully labeled histogram. What do you need? You need a column for boundaries. You need a column for frequency. You need a column for class width. Frequency divided by class width is frequency density. And then you need a column for the height in centimeters that will be based upon scaling. And you obtain a histogram. What about the first part? Estimates of mean and standard deviation. We have done a lot of questions. Take the mid value. What is the mid value? 2.5 and 7.5, and this is 15, and this is 25, and this is 35, and this is 110 divided by 2, which is 55, and then make a column for x and f and x square and fx and fx square and all those formulas, and you get the answer. That's not a big deal. Look at question number 25. Question number 25 says the floor areas of 20 factories are as follows. It's already given in ascending order. Looks like a stem plot, but it's not. Data is given, arranged neatly in ascending order. Represent these data by a histogram on graph paper using the intervals as shown. That means you have to count how many values belong in each category. How many values do you see that lies between 0 and 500? I see a 150, 350, 450. So 3 values. Between 500 and 1000, 578, 595, 644, 722, 798, 802, 904, and 1000 itself. Now, in the first in the first category, 1000 is not inclusive. So 1000 will go in the next one, and so on. So it's just counting, filling in the table, keeping a track of it by the tally marks. And that's how you do it. And the rest is pretty simple. You have class boundaries, you have frequency, you have class width, frequency density, and the height. And it's the same usual pattern. Again, we see a 5-step procedure in this, a 5-column procedure. Okay, now let's look at this question. The length of cars traveling on a car ferry are noted. The results are summarized in the following table. Read the question for a while. How is it different? How it's the same? This time, they have given us the frequency density, and they are asking us to calculate an unknown constant. Can we do that? Which formula can we use? We can use the concept of frequency density is frequency over class width. Now, first of all, what is the class width? 3.40 minus 3.20, that is 0.20, that is class width. Class frequency is 8, and frequency density is A. A simple calculation. That simple calculation is frequency density is class frequency over class width. Frequency density is A, class frequency is 8, class width is 0.2. 0.2 is 1 over 5. So when you do this thing, you get the answer as 40. So there were 40 cars that belong to the last category, 3.2 till 3.4. That thing is done. Now it says, find the probability that a randomly chosen car on the ferry is less than 3.20 meter in length. A simple probability question. Randomly, one car is chosen. So therefore, 17 plus 24 plus 19 plus 8. How much is this? This is 25, and 24, that's 49. 49 plus 19, that is 68. So 68 will be the denominator. That's the first thing. The length is less than 3.2. So length less than 3.2 could be this, could be this, could be this. That should be the numerator. That should be 17 plus 24 plus 19. Basically, 60 goes up the top, 68 goes down, and that is the answer. So a simple O-level math calculation regarding probability based upon a frequency distribution. Okay, Ji. Let's look at this question. The following table shows the result of a survey to find the average daily time in minutes that a group of school children spent in internet chat rooms. Those were the days. So now the mean time was calculated to be 27.5. Form an equation in X and find the total number of children. That standard deviation is such. This is not a frequency distribution. This is not a histogram question, but a simple frequency distribution question. So this is X, this is F. Apply the formula X bar, which is sigma Fx over sigma F. So this just came out of the blue. This question is just like a simple one. You have the boundaries. It's already the boundaries, or do you have the intervals? It's finishing at 0.5, starting at 0.6, finishing at 1, starting at 1.1, finishing at 2, starting at 2.1. Now the rule is, this is 0.5 to 0.6, sorry, 0.1 to 0.5. Let me write this thing as 0.10 to 0.50, 0.60 to 1.00, 1.10 to 2.00. These are class intervals. How will you change it into class boundaries? What is the difference between 50 and 60? If I ignore the decimal, there is a difference of 10. So you add 5, you subtract 5. That means this one will become 0.05, just the concept of O-level math, and this is 0.55. This is 0.55, this is 1.05. This is 1.05, this is 2.05, and so on. So the first thing was, in order to draw a histogram, class boundaries is a must. The rest of the things will definitely come in. That is about the class width and the frequency density and the height. That definitely would come. So this was the thing that looked like a simple question, but it was not so simple because the data was not given in boundaries. It was given in intervals. Last question for today. The weights in gram of the number of stones measured correctly to the nearest gram are represented in the following table. And then it says a histogram is drawn with a scale of 1 centimeter equals to 1 unit. That means the height is the same thing as frequency density. So keep that in mind. Vertical axis, which represents frequency density, the 1 to 10 triangle has a height of 3 centimeter. Now let me draw a bar. This is 1 to 10, first of all. This will become 0.5 to 10.5 and 10.5 to 20.5 and so on. So first thing was changing into boundary. This is 0.5. This is 10.5. The class width is 10. That's the first thing. The height is 3 centimeter. 3 centimeter means 3 units of frequency density. That means the area of this bar, the area is the frequency. That comes out to be 3 into 10, that is 30. It's asking us the value of x. So 3x is equals to 30. Agreed? The frequency is 30. Therefore, 3x is equals to 30. Therefore, x comes out to be 10. And now it's asking us the height of the 51 to 70 rectangle. Let's see. For the 51 to 70 rectangle, what information do I have? First of all, that is 50.5 to 70.5. So therefore, the class width is 20 units. The frequency is x, but we said x is 10. That thing is done. Therefore, frequency density is a class frequency over class width. That is 10 divided by 20. That comes out to be 0.5. And it's asking for the height. 1 centimeter is equals to 1 unit of frequency density. Therefore, 0.5 means 0.5 centimeters. Have a look at it again. It's basic O-level math, a simple multiplication that we are using. The main thing is understanding that the area of this rectangle represents frequency. The area of this rectangle can be obtained by multiplying the height with the width. The height is the frequency density. The width is the class width. In order to find the width, what is necessary? What is necessary is that you should be working in boundaries and not in interval. That finishes the lecture of frequency distribution, diagrammatic representation, which is called a histogram.